Assalamualaikum to our lecturer, Dr. Waheed Ali Ghanem, and to my fellow friend. Today we are from Group 8. We present the algorithm, Bridge versus BFS, and Bellman-Ford algorithm, BFA. Okay, this is my group member. The first one is Aidil Wajidi bin Izham, Muhammad Alif Akbar bin Muhammad Nizam, Muhammad Ikhwan bin Muhammad Fadil, Muhammad Mustaqim bin Muhammad Nur Sapian, Muhammad Azim bin Saleh, and Ismi Siti Nur Atika binti Yahya. For our list of the content for presentation today, we have a background, measurement, analysis, and conclusion. And for the background, we show the Bridge versus and Bellman-Ford algorithm. And for the measurement, we measure the concept and the rule of the both algorithm, and we also provide the explanation of the algorithm based on the sample of question. And for the analysis, we have demonstration of Java algorithm, which will hold by Alif Akbar, and the output of Java algorithm based on our Java coding. And the last one is conclusion. We show the application of each algorithm, which is BFS and BFA algorithm, and advantages and disadvantages of the algorithm. Okay, for the next, to show our first algorithm one is Bridge versus, I will give to the Muhammad Ikhwan to continue.
Okay, thank you to Nur Atika for the introduction of our presentation on our project. So I will start my presentation about the breadth first search, or simply we call as BFS. So next. All right. So breadth first search. Okay. BFS is actually used for the traversal of a graph, or similar to breadth for the tree form beside of the graph form, and the traversal of the graph is visiting exactly one each vertex or node, and each in a well-defined order. By the way, beside the name of breadth first search, we also can name it as the breadth first traverse. It's similar to the BFS actually. So the third point is it can keep track of the vertices those have been visited, so that the same vertex is not traversed twice, and the traversing start from a selected node or source node, and the traverser continues through the nodes directly connected to the source code. And algorithm 1 should first horizontally move and traverse the current layer, after which move to the next layer to be done. Next. So for the concept of the BFS, this algorithm actually traverses a graph, same with the previous slide that I mentioned on the explanation itself. So I will proceed with the third point, which is the time complexity is these are the formula regarding all of this concept of the BFS, where V actually is the number of vertices, and the E is the number of edges. And it used the opposite strategy, which instead explore the node branch as far as possible before being forced to return back and discover or move to another node. Okay, next. So these are the rules that need to be followed up by the if we apply this concept. First one is we need to ensure that when we visit the unvisited node, after we visit the node, mark it as visited and insert it in a queue. And for the stage 2, if no node or vertex is found, remove the first node from the queue list. And the third stage is repeat route 1 and route 2 until the queue is empty, and they will have been marked all the nodes. Okay, next. So these are the example, the formation of our concept that we apply. I mean the project that we apply in this kind of concept. So in here we got five nodes, which are post office, kedai awet, FTKKI, masjid, and also UMT. So we want to track the user to understand what is meant by the BFS actually. So in here, about the distance, which all distance we assume as one, and if we can see in here, there is no visited mark have been marked on all the nodes because the flow of the system still not be conducted, right? So the BFF program is traverses from post office as the root node to UMT and Kedawet to Masjid and lastly to FTKKI. So there are 5 vertices at that form and 5 edges. Okay, next. So at first, step 1, we should see that set post office as root node or starting node and mark as visited. So actually we can highlight the first node or just simply cross the node. So after we cross the office, uh, it will be two side of nodes that will be headed to be visit after the post of the nodes, which is UMT and Kedawet. So the UMT and Kedawet nodes will be listed on the queue status, right? Next. So after the visit on the post office node at first, so it will continue to the UMT node and will be marked as visited. And after it been marked as visited, the list of UMT node will be uh, uh, delete out by the queue status and will be list out as the DQ status. So it will be the kedawet node will be as the single of the node that will be stated on the queue status. Right, next. And after done with the UMT nodes, so it will continue to the kedawet. So after visit the kedawet, so it is compulsory to mark as the visit status for the kedai awet. So after the kedai awet done, after done with the kedai awet visit process, so of course after it will be two nodes that need to be visit and be listed on the queue status, which are masjid and also FTKKI. Next. And of course after done with the visit the masjid, so need to be marked with the visited marks on the masjid notes, and the masjid node will be delete from the queue status and will be list in the queue status, and only the FTKKI that still not be visited will be listed in the queue status. And lastly, after done masjid visit, after done with the visit on the masjid node, so it will continue to the FTKKI node, and after done with the visit of the FTKKI node, it will mark as visited and will be delete from the queue status and will be listed in the queue status itself. So this the FTKKI node will be as the last node that need to be visited, and after done all the nodes, it means that the system had been visit all the nodes. I mean the process is done. Okay, so I will pass the explanation on the demonstration of the program to Alif.
Okay, I will explain about the implementation of the BFS. Okay, since we know BSF can be implemented in many ways, and I choose we implement the BSF into the GPS like application. So in this application, we have two objects. which buildings that defines the building, and the maps that the buildings will be located. So in the buildings object, we have the set name, set building number, and everything about the building, defining the building. And the map object, we have the pre-map, count max route, and okay, add route, pre-map, and max count route. Okay, for the add route, we have a list of buildings, list of array buildings that having the connection name, connecting building, and we have the two building that we want to connect. Okay, for the pre-map, we will be print all the connection with the building list. And for the count max route, we have the formula for the formula to achieve the maximum number of edge of complete graph. I mean, all the edge will have every graph, every vertex. Okay, for the map, for the main application, we have the scanner, Java scanner, Java miss input exception for exception handling, release for facilitate the array. Okay, first we will going to have the user to sorry. First we will explain. We will create the array for buildings, number of array. Okay, for that, we will ask the user to enter the total names that they want to, the total number of building that they want. And down here, we will have the exception handling. For this one, after they put the number they want, the number of building they want, they will add the name of the wait. Yes, they will put names on the building, number of building. Let's say they put 4 buildings, so they need to add 4 name for 4 buildings. And after that, the array list connecting buildings. This connecting buildings is the defining the connection between buildings. So it stores about the size of the user entered just now, the number of buildings. Okay, this is where the connection is built. We add new list in. We add new. The connection info into the connecting building. All right. So the user get to choose how many road they want to put, but the number of road must not exceed the maximum road, because the maximum roads is defined of the perfect graph. So if they put more than the perfect graph, then they need to put it again. Okay, this is where the system show what building the user put. Okay, this one. Wait. Okay, this one is where the user decide which building connecting to which building as building 1. This is for the user input for building 1. This is for the user input for building 2. Okay, wait. Okay, this is the exception handling, as if the number of the buildings is not, if the user put 4 buildings, so if the user put earlier, the user put 4, so as if they put 5 here, there will be an error. So this is for the exception handling. Okay, this is the application adding the road into the connecting building. This is the controller and exception handling. Okay, this is where the application create a maps for the connection created. Okay, this is our object map as map 1 of the object of map. Okay, that's all. That's all from me. We will try to execute the system. Okay, let's start. And this is where we decide to put how many buildings we want. Let's say we put 4, and the name of the buildings for building 1. This is for the building 2. This is for building 3. This is for the building 4. 5. 4. Okay. This is the how many road we want to put inside the map. Let's say because map got road, so this road is defined here. Let's say we want to put 2. Now we get to choose which building is connecting to which building. Let's say I see post office with the police station and post office with the bank. Okay, so here this is what map object is printing. This map 1 print map, so they print this one. Post office is connecting to the police station and bank, so police station is connecting to post office and bank is connecting to post office. All right. Okay, this is the just in case you want to continue or just press and enter. So if you don't want to continue, just press 0. All right. That's all for me.
For the application of brace versus, we have a tree that we want to show. The first one is shortest path and minimum spanning tree on unweighted graph. Like the example of question, like we see letters that are shown by Ikhwan. On the unweighted graph, the shortest path is at least number of A's. With briefest, we always reach a vertex with a given source using a minimum number of A's. Also in the case of unweighted graph, any spanning tree is minimum spanning tree. We also can use diff or breadth first traversal for finding a spanning tree. And for our algorithm, we use BFS. And the next application of BFS is peer-to-peer network. It's very close with our life, which in the peer network like BitTorrent. The first is used to find all neighbor nodes. So by the peer-to-peer network, we can see how the computer interact each other. And the next is social networking website. In social network, we can find people with given distance k from a person using BFS till the k neighbors. Okay. And the advantage of BFS, BFS, then the advantage is BFS, we never get trapped exploring the useless path forever. It means BFS we give us the shortest way to show like a location in the application. And the next, if there is solution, BFS is definitely find out. It show the BFS also the easy to understand and easy to we can analyze. And the next, if there is more than one solution BFS, can find minimum one that requires less number of steps. It's like my explanation before. And the disadvantages or drawback of BFS. For the memory requirement, since each level of tree must be saved in order, so it's need more memory to keep the data. If the solution is further away from the root, BFS also consume a lot of the time. Okay, for the next, we continue algorithm 2. Bellman-Ford algorithm will be presented by Muhammad Azim bin Saleh.
Hello, Assalamualaikum. My name is Muhammad Azim Saleh and my metric number is S55286. Now I would like to represent about BFS, Bellman-Ford algorithm. There are 3 rules in BFS, which means step 1 is we need to analyze distance from source to all vertices from its distance, which is itself s equal to 0. Step 2, we need to calculate the shortest distance, and step 3, we need to report if there are negative weight cycle in the graph. How Bellman-Ford algorithm work? We need to investigate the graph, and we can see that there are 5 vertices, which means A, B, C, D, E, with 10 edges. And the graph are started from vertex A. That's vertex A have 0 value. Step 1, initialize the information. Vertices have 5, edges have 10, and we need to know the vertex that link with the edges. That's which means the edges have AB, AC, BD, BC, DE, DB, CD, CE, EA, and ED. These edges can be sorted randomly, and we need to know the weight of each edges. And after we know the vertices have the graph have 5 vertices, so that we will know that there will be 5 iterations. During the iteration, the specific edge will relax or known as updating the distance to destinate the each edge. For step 2, we need to create a table which is row, have I for iteration, and distance array for value weight of edge from distance to destination. We can see in the picture, as we know that vertex A has value 0, so the A will be the starting vertices in the graph, and the other vertices will remain infinite because we don't know the value. For step 3 will form the first iteration. For first iteration, from vertex A equal to 0, we must add the value that link to the vertex A, such as edges for AB have weight 6 and edges AC have weight 7, and the other vertices will remain infinite. For step 4, we will form iteration 2. As we can see the picture, the final result for iteration 2 is distance A 0, distance B 6, distance C 7, distance D 4, and distance E 8. For vertex A, the shortest distance is 0 because we know that 0 is less than 2. For vertex B, the shortest path is equal to 6, and for vertex C, the shortest path is 7. For vertex D, the shortest path is 4. That's AC plus CD. You can see that AC is 7 and CD is -3, so 7 plus -3 equal to 4. And for vertex E, the shortest path is 8. That's AB plus BE. AB 6 plus 2 8. For step 5, we will form iteration 3. and the picture have show the result. So for vertex A, the shortest path is 0. For vertex B, the shortest path is 2, y2, because in iteration 4 we have get the value vertex D is 4 and vertex D to vertex B is -2. So for vertex B, the shortest path is AC, CD, DB. So which means vertex D plus edges D to B 2. For vertex C, the shortest path is 7. For vertex D, the shortest path is 4. That vertex C plus edges C to D, and vertex E, the shortest path is 8. For step 6, we will form the iteration 4, which means the final iteration. For vertex A, the shortest path will remain same, that's 0. For vertex B, the shortest path is 2, still same. For vertex C, the shortest path is 7, still remain same. For vertex D, also remain same, that the shortest path is 4. And for vertex E, the shortest path have changed, that we can see in iteration 3. The shortest path for vertex E is 8, but for the iteration 4, the shortest path is 4 because of the change value of vertices B. As we can see, B have 2 and plus the weight of BE 2 and section for E is 4 and the value for E is 4. But if we use the value of C to E, that 7 plus 9, it will equal to 16. The 4 is lower than 16, so the shortest path is B to E. And from all the value, we can fill into the graph to see the clear view for shortest path. So the shortest path is such as the picture, that vertex A has 0 value plus 7. Vertex C we have 7 value of 7, and the weight of C to D is -3. So the vertex D will have value 4. The weight D to B is -2. So the vertex B will have value equal to 2, and the weight B to E is 2. So vertex E we have value 4, 2 plus 2, and the shortest path is A to C to D to B and to E.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ustakim bin Muhammad Sipian, and I will demonstrate about the Bellman-Ford algorithm code. Okay, wait for the first line. We use the import java.ut, import java.line, import java.io, and import java.ut.scanner because we want to get the input from the user. Okay, the first one is we make class. This class is to represent a connected, directed, and weight graph. And after that, we make a subclass, class H. And this class is to represent a weight H in a graph. After that, we create another subclass. It is to create a graph when is V is the variable for vertex and E is the variable for H. Okay. After that, we make a function. This is the syntax. The function is the main function that find the shortest distance from source to all other vertices using Bellman-Ford algorithm. The function also detect negative weight cycle. Okay, for step 1, we use the loop syntax. The syntax is to initialize the distance from the source to all other vertices as infinite. For step 2, we also use the loop syntax to relax all the edge minus 1 time as a simple shorter path from the source to any other vertex can have at most minus 1 edge. After that, we step 3, we also use the loop syntax. This syntax is for checking the for negative weight cycle. The above syntax guarantees the shorter distance if class do not have do not have negative weight cycle. If we get a shortest path, then there is a cycle. Okay. After that, we make a alternative function that used to print the solution. Okay. After that, we make a method to test above all the function. Let's say the code is like this, and we scanner to get the input from the user. Okay, this. For this syntax is for the find value of vertex and edge, and this is an array. The array is for the user to insert data for each vertex to get value of source, value of distance, and value of weight. Okay, we run this code. Okay, this is an example that I made before. The value of vertex is 7 and the value of edge is 4. You see the data that entered by the user, and this is the output, which is the vertex distance on the source. It is the shorter path distance. Okay, that's all from me. Thank you.
Okay, for the application of BFA, first, distance vector routing protocol. This protocol decide how data packets on a network can be routed. The distance equation to calculate network weight is the number of routers through which a certain path must pass to reach its destination. Okay, next, global positioning system or GPS. GPS consists of 24 satellites to provide worldwide position, time, and velocity information. The system calculates the distance from source to every node in the graph. From this, it can estimate the shortest path. Okay, next, road finding in video game. In role-playing game such as Genshin Impact, this road finding is a good alternative for gamers as assistant to go at any part of virtual map. Okay, here we prepare two example. If the user click at any navigate button, the system will show the yellow line. Means that it is the shortest route to the destination. Next. Okay, for the advantages of the Bellman-Ford algorithm, BFA has a BFA more complex than Dijkstra algorithm. BFA also can handle direct and indirect graph with no negative weight. Also, BFA can only handle direct graph with negative weight as long as we don't have negative cycle. So we can find the negative cycle with BFA. Okay, for the disadvantage of Bellman-Ford algorithm, it can only work for direct graph and require local information. Okay, that's all from us. Thank you.